Hi everyone, today's lesson is on the properties of rhombi and squares. So we are still talking about special parallelograms, and the first one we're going to talk about is a rhombus. So a rhombus is a special parallelogram with 4 congruent sides. So every single side is going to be congruent to each other. All right, now because a rhombus is a parallelogram, it's going to have all those same properties of a parallelogram. So we know the opposite sides are parallel and congruent. Specifically with a rhombus, all 4 sides are congruent, like we said. Opposite angles are congruent. Consecutive angles are supplementary. And the diagonals bisect each other, okay? Now, the following 3 properties are specifically just true for a rhombus. So, like we said, we have 4 congruent sides. And the diagonals, we're going to have 2 properties about diagonals. So I'm going to just draw these in so we can get them nice and straight and accurate. The first property of a diagonal of a rhombus is that they are going to be perpendicular. So the 2 diagonals are going to intersect and form a right angle. And then they are also going to bisect opposite angles. So what that means is I have these 2 opposite angles here. This diagonal is going to bisect them. And because I know that my opposite angles are congruent, because this is a parallelogram, these 4 angles are all going to be congruent. And then these 4 angles are all going to be congruent. Okay? So our first set of problems here, we've done a couple of these before in other videos. We're going to identify the property of a rhombus that is being depicted and then solve for the missing variable. So if I look at number 1, clearly I'm talking about my sides here. I know that all of my sides are congruent. So that's my property here, is that I have 4 congruent sides. So I'm going to set 6x minus 5 equal to 3x plus 7. So to solve for x, I'm going to subtract 3x from both sides. Add 5. And 3x equals 12. So when I divide all sides by 3, x equals 4. Now, my next problem here, I'm looking at the diagonals of a rhombus, and I'm specifically looking at that angle where they intersect. Because my diagonals are perpendicular, I know that's going to be a right angle, so I'm going to use my diagonals perpendicular property to set 7x plus 6 equal to 90. So subtract 6 from both sides, 7x equals 84. And x equals 12. Okay, next for number 3, I am looking at my diagonals again, but here I have, and if I go back up here, I see that I have my diagonals bisect opposite angles because I have this opposite angle, or I have this angle here. It is being bisected by that diagonal. So I can say that the diagonals bisect opposite angles. We're going to abbreviate there. And we're going to set 6x minus 2 equal to 28. So 6x equals 30. Divide both sides by 6, and x equals 5. Okay. And then finally with number 4, I'm again talking about the diagonals. Here I'm specifically looking at the, I'm not looking at angle measures, I'm looking at segment lengths. So here I still want to use my diagonals are perpendicular. And I'm going to use that with the Pythagorean theorem. So if I know this is a right angle, I know that I can use the Pythagorean theorem here to solve for x. Because this is a parallelogram, I know my diagonals are not just perpendicular, but they also bisect each other. So if this piece here is 9, this piece here is also going to be 9. So I can set up my Pythagorean theorem, x squared plus 9 squared equals 18 squared. So x squared plus 81 equals 324. And when I subtract 81 from both sides, I'm going to get x squared equals 243. Take the square root of both sides. If you're simplifying your radical, that's going to simplify to 9 times the square root of 3. Or if we're plugging this into a calculator and getting a decimal, we're going to get 15.6. So our answer here is going to be whatever you're using in your class, either 9 root 3 or 15.6. More properties of rhombuses. Here we have this rhombus RSTU. We want to find the measure of angle SUR. So here I'm looking at these two angles, and they're not one of the four or a pair of angles that are going to be congruent to each other. But because I know that my diagonals are perpendicular, I do have that right angle that I can work with. So looking at this triangle here, if I have a right triangle, I know that the other two angles in my right triangle have to add up to 90 degrees. So I can set 5x minus 6 plus 7x equal to 90 degrees. So I have 12x minus 6 equals 90. And I'm going to get x to equal 8. Now, that's not what the problem's asking me for. The problem is asking me to find the measure of angle SUR. So the measure of SUR is going to be 7 times 8 or 56 degrees. Okay, and then if I'm looking at this rhombus LMNO, I see I have a diagonal. It's bisecting those opposite angles. So here I'm going to have these angles congruent. So 5x minus 4 equals 2x plus 14. And I'm going to solve for x. So x equals 6. And then substitute that in for the measure of angle LMO. So 2 times 6 plus 14 is going to be 26 degrees. All right, now number 7 is one of those problems where we have to solve for a whole bunch of different measurements here. All right, so it says ABCD is a rhombus where AE is 5, so I'm going to put that in right there. BD is 24, so that whole diagonal is 24. And it tells me that the measure of angle ADC, so that whole angle is 58 degrees. So first thing I want to find is DE. So if my whole diagonal is 24, I know that the diagonals bisect each other. So DE is going to be 12 and EB is going to be 12. So I'm going to put that in for both of them. Now I want to find AB. So again, I have this right triangle here. All right, and I know it's a right triangle, all right, because my diagonals my diagonals are perpendicular. All right, so here I can set up the Pythagorean theorem, 5 squared plus 12 squared equals x squared. And this is one of my Pythagorean triples. 5 squared plus 12 squared is going to be 169. So x would equal 13 here if I take the square root of both sides. So AB is going to be 13. If I want to find BC, that is also going to be 13 because this is a rhombus. So all of my sides are going to be congruent. And then I want to find BD here, which is just 24. We already knew that. All right. Now let's look at our angles. So I'm going to erase, all right, everything we have here to help us find our angle. So we did know that that whole angle was 58 degrees, and I'm going to leave in those diagonals being perpendicular. So if I want to find the measure of angle DEA, right, I know that has to be 90 degrees because my diagonals are perpendicular. Then I'm going to find the measure of angle ADB. So my diagonals bisect the opposite angles. So I'm going to take 58, divide that by 2, and each of these angles is going to be 29 degrees. All right, so that guy there is also 29 degrees. All right, so I also know this one's 29 and this angle is 29. Okay, now I want to find the measure of angle DAC next, right? So that's one right here. And what I can do is I can take this angle is 58, so I know this whole angle is going to be 58. So this angle DAB here is going to be 180 degrees minus 58 because these are supplementary angles. So I have 122 degrees, and half of that is going to be 61. Okay, I also could have used this right angle here, all right, and done, looked at this right triangle, done 180 minus 90 minus 29 to get 61. Okay, so a whole bunch of different ways that you can think of it. If this angle is 61, I know this angle is 61. Angle DCB is the next one we're looking for. We found angle DAB, that whole angle, to be 122 degrees. So this angle DCB is going to be 122 degrees because those are opposite angles. And the last angle that we're looking for, angle ABC, we already know is 58 degrees. Okay, so that's pretty much it for a rhombus. Now, our last special parallelogram that we're going to talk about is a square. And a square is going to be a parallelogram with 4 congruent sides and 4 right angles. So basically, a square has all of our properties of a rhombus and a rectangle. Okay, so a square is going to have every single property that we have talked about so far with parallelograms and special parallelograms, because a square is a parallelogram, it's a rectangle, and it's a rhombus. So we know the opposite sides are going to be parallel. They are also going to be congruent. The opposite angles are congruent. The consecutive angles are supplementary. The diagonals bisect each other. There are 4 right angles, and the diagonals are congruent. Those were our 2 properties of rectangles. Then we're going to have 4 congruent sides. The diagonals are perpendicular. And the diagonals bisect opposite angles. So the top 5 properties were our properties of a parallelogram. The first 2 on that bottom row are our properties of a rectangle, and then these last 3 are the properties of a rhombus, which we've just talked about. Okay, so we're going to look at this square below, square ABCD. All we know here is that BC is 8, but we're going to use that to find all of these measures. So because this is a square, I know I'm going to have all 4 sides congruent, right? So this is going to be 8, 8, and 8. So the length of AB is 8. The length of AD is also 8. If I want to find the length of BD, all right, because I know that I have 4 right angles, I can use my Pythagorean theorem there. So 8 squared plus 8 squared equals x squared. So I'm going to have 64 plus 64. And I'm just going to flip that x squared around. X squared is 128. And when I simplify that, I'm going to use simplified radicals here. That's going to be 8 radical 2. So the diagonal is 8 root 2. If I want to find this segment here, EC, right? If I know this whole diagonal is 8 root 2, that means AC is going to be 8 root 2, and EC is going to be half of that. So that's going to be 4 root 2, right? And that's all of my sides. So let's just kind of clean, or segment lengths, I should say, that I'm looking for. Now I want to find the measure of BCD. I already marked that as a 90-degree angle. All right, so I'm good there. The measure of angle BEC, those look like my diagonals, which are perpendicular. So that would also be 90 degrees. The measure of angle ACB is going to be half of 90 degrees because this square is a rhombus. It's going to bisect opposite angles. And 90 divided by 2 is 45. So ACB is going to be 45 degrees. The measure of DAC is also going to be 45 degrees. And then ADC is also going to be 90 degrees. So you can see with this square, we're using every single one of those properties that we've talked about since we've been talking about parallelograms and special parallelograms. And that wraps up everything on special parallelograms. Thanks for watching. You can comment below if you have any questions.